Alright, so here is my TimSort project. First thing, let's look at the TimSort function itself. First important thing to notice is we have this min merge up here. Basically, this is what is called the run, and this is important because when you get really large arrays, so it has like 1,000 elements, we need to split into 32 element arrays, and that's the individual arrays we will then merge and do our TimSort with. So the first thing we do is we establish an n value, that's the array length, and a j value that's set to 0 that we'll come back to. Then we check to make sure that the array length is greater than the merge or equal to the merge. We want it to be greater than, because otherwise you're just wasting your time splitting it and doing all this other stuff when you can just call the insertion sort. We'll come back to insertion sort later. So the next case is where it is greater than 32, or our run. And what we do here, the way I did it, is we have a while loop that goes from j until it is the equal to or greater than that n value of number of elements. And j, as you can see here, will iterate every loop. It will add the 32 to it. So the first thing we do here is we're going to create a new integer array that holds the current run, and we use run size. And the reason we have to call this math min run size here to get the integer of that is because if we're the last element and it's not a multiple of 32, we're going to have a 32 element array, but there's only 30 things in it, so we're going to have two null values, and it's going to cause an error. So we need to do this just for that last case. Then what we do is we populate it. So we have this loop that goes for the run size, and we do this again, like I said, because if it's 30 elements, you don't want to go 32 times. And what we do is we go j plus I of the actual array, and we put that into the current run I. So if we move over, so the first 0 through 31 will populate 0 through 31 for both of them, but then it's 0 through 31 for run, and 32 through 63 for the array. Then we call the insertion sort for run, and the thing we do after that, the last thing we do here, is we have a loop that takes what we got from run, this newly sorted 32 element array, and we're going to repopulate its portion. So if it was the first 32 elements, those first 32 elements are now repopulated with that sorted array. Last thing we do is call the merge sort. So if we go down here, insertion sort, how does this one work? We are basically just going to loop through the array, and what we're going to do is we're going to establish a temporary value every time, and we're going to set j to be 1 less than I currently, and array I, so the current value we're at is the temporary value, and then we have a while loop here to check every other value behind it to see, was it greater than, so is our current value greater than the temporary value, and if it is, we'll switch it, and then this case will no longer be true, and we'll drop out, and array becomes a temporary value. So this will basically just sort it. The next thing that's really important to look at is the merge sorts. How do the merge sorts work? This one's kind of a long one, but basically we have a case here where first thing we do is we set n to be the entire length, then we check if n is less than 1, so are we to a point now where there's fully sorted or not. And then we need to establish a left and right, so we take the mid by dividing n by 2, so we know how large it should be, and the left will just be the mid, so 0 to the mid, and the right will be n minus mid. This is because, for example, if it divided and you got like a 0.5, then if you have just mid and mid, you're going to lose one element that you should have. So we call these two loops that populate it, and they populate, as you can see, from the mid and to the mid. If you look at these correctly, see mid to I under less than n, 0 to mid, right? And then we call the left and right merge sort of both of them. The next thing we have to do is we create a new result array, and we establish 3 integers at I, j, and k to establish a left, right, and result. And we call a while loop for them that goes from the lengths of both until one of them is done. So we've gone through the whole length, and we will iterate I and j, setting k value to be the result. And basically all we do is we compare, is the left side's value greater than the right side, which would mean those 32 have to be moved. So we do these, and then we have to have these 2 other while loops that basically do the exact same thing, but we iterate through the left side and the right side individually, because let's say the left side had 32 elements and the right side had 33 or 31. Then we're going to end that first loop early, and we need to now compare to make that last one go in. So if we look at the main runner here, see it runs, and if you look to the left, all the tests run as well. So there we go. It's my TimSort.